Hello, welcome to Dev Radio. I am here with Amit Mukherjee, who is a cloud solution architect, and he'll be one of our coaches for the upcoming OpenAI Hackathon that starts this Thursday. Thanks for joining us, and you're going to tell us about advanced prompt engineering, right?
Yep, thanks. Is right, Matthew. So we're gonna talk about the advanced prompt engineering, different tips and techniques. And this is, one of the most important topic in generative AI, especially the large language models, right? And that's where people sometimes, get a little bit confused that what is this prompt engineering? How I can write a better prompt? What are the different tips and techniques? And there are many in the internet, but I'm going to try to summarize in a better way and give the audience a complete picture of the different prompt engineering techniques, how they can use it, and how they can make their prompt better, and what are the different additional learning resources so that they can go after this presentation and look around that.
Great, let's get started. Do you have a presentation to start with, or?
Yeah, let's start with the presentation. I'm really excited. Let me
Okay,
bring the presentation mode. Yeah, is that all looks good?
looks good.
Awesome. Let's get started. So, as I said, I'm a principal cloud solutions architect. So, I mainly focus on Azure OpenAI. And today we're going to talk about advanced prompt engineering. But before we start, let's have a quick set of agenda. So, there's a specific two agenda. What is prompt engineering, the intro of the prompt engineering. And then we're going to dive deeper on the different tips and techniques of the advanced prompt engineering. Now, first of all, first thing first, what is prompt engineering? So the prompt engineering, it's a very next skill nowadays, right? And one of the hottest programming language nowadays is English, right? If you know English better, you can write your prompt better. So, and the prompt engineering is basically it's telling the large language models what instruction you are passing to the models and what output you want to get out of the model. These are the two things, right? And in fact, before I join this call, I just write my Azure OpenAI, what is prompt engineering, right? And this is the response I get. It's that prompt engineering is the process of designing and refining prompts and effectively communicate with AI language models. So see that how it's like it? Effectively communicate with AI language. That's the reason I said English is the new programming language. So, like Azure OpenAI, in fact, Azure OpenAI, the GPT-3 and other models, right? So, it involves creating questions, statements, instruction, and guide the AI to produce desired response and perform a specific task. The goal of prompt engineering to optimize the interactions between human and AI, ensuring that AI understands the user intent and provides accurate, relevant, and useful information for assistance, right? And this process often requires experimental testing, iterations, and find the most effective prompts for a given task or content. So just just put in focus on the last statement. This process often requires experimentations, testing, and iterations to find the most effective prompts for a given task or context. What does it mean? Prompt engineering is not a once you write it and you done for the whole life. No, it's an iterative process. Nobody can say that this is the best prompt for your applications. No, the prompt you write a prompt means that instruction given to the model, you get back the response, and you see that how the response is coming up from the prompt, and you may try to a little bit change the prompt and see what the other response is coming. So it's a iterative process. Keep on continuing doing it to give you better and better and better results, right? And there is no certain point I can say that, hey, this is the point you should write the prompt and this is the response you should get. No, it's all depends where you feel that this is the best output you are getting, and that's where you can stop it and you can keep iterating to give more and more better, right? That's need to be remembered. So in short, the prompt engineering is kind of a process, iterative process. You have to keep on writing, giving you the better response. And that's, in fact, I'm seeing the future. The prompt engineering will be one of the very next skills in the coming era of generative AI, which people has to adhere as part of their other skills. And without that skill, I think the scope of your application to getting sophisticated will be much, much, much more hard. Okay, now we're going to talk about some basic things before we go to the advanced stuff of the prompt engineering. First of all, what are the different elements of prompt, right? So in the down, I have provided examples of a particular prompt. So typically, a prompt has around 4 to 5, and the reason I said 4 to 5, some prompts you'll see that four, some prompt could be five elements are there. One first thing is instruction, means that this, if you see the example, right, classify the following news headline into one of the following categories: business, tech, politics, sports, and entertainment. This is the called instruction. So you are telling the model what the model has to perform. That's called instruction, right? And then I'm going to come to context later, but then we are giving some examples. For example, we are giving here, Donna Stephen is cooking up a new kind of perfection, the internet most beloved cooking guru, as a buzz new book and a fresh new perspective. And the category you did is doesn't done by the model. You did say it's an entertainment. So this is an example you are feeding to the model along with the instruction, right? That's called example. And then you provide your new input data, means now that is the kind of a question you are asking to model to predict what would be the category for this particular statement, right? That's called input data. And then we have an output indicator, which is just a category, not the green part, just the this regular the black letters category. That's an indicator. You are telling the model, okay, you want to model has to predict the actual category of this above statement and come up the results in the category tag, right? And model predicted it's a business, which is seems to be correct, right? So instruction, you are telling model what need to perform. Examples, you are giving some examples to the model so that model can steer towards particular examples and give you the actual result for your actual input data, and you put an output indicator. Now, we'll go later about some other techniques about detail, but this examples is not necessary. You have to give every time. Is good to have for sure, but even if you don't provide that example, that's okay. It can produce you the results. We'll not judge about the quality right now, but it is possible without having an example, right? Now, I haven't touched about the context part. The context is also important in some cases. We're going to go more deeper on that time. We're going to talk about the context piece. But the context, think about you are producing a question answer for a given text, right? And then the given text is become a context, right? So you said, for example, you tell the model that, okay, your job is to find the right answer from a given questions by the user for the given text, right? And then you provide the text, and then you embed the whole text here, right? That text become the context at that point, right? We're going to go to the example and it will be much more clear. But typically, instruction, context, example, input data, and output data, these are the element to define a particular prompt. Now, let's go different principles of the prompting. The principle number one, you always write clear and specific instruction. Principle number two, give the model time to think. Same goes by the human. If I ask you to do something and if I don't give you a specific instruction, I will not get the desired output from you, right? It's a pretty human. And at the same time, I had to time to the person to think before the answer, right? It's a pretty simple thing. I need to tell you what needs to be done, and then I also need to give you time to think before you respond back to me. These are the two principles applies for prompting for large language models. Pretty easy. Now, principle number one, we said write clear and specific instruction. Now, what are the different tactics for that? Tactic number one, use delimiters to clearly indicate distinct part of the input, right? So here you see that I have a given text, and I have in the f string, I have provided the text, and then I am telling the actual prompt, which is an instruction, summarize the text delimited by the triple backticks into a single sentence, right? It's a pretty clear and specific instruction. Why it is clear? Because I said summarize the text delimited by triple backtick. So very clear what need to be used to summarize that statement, right? And then I'm saying into a single sentence. That's a very precise instruction, very clear and precise instruction. Now in the text, and by the way, I'm just sometimes fishing on that screen, and doesn't mean that I'm doing something different because I have a dual mode. Look at that here. So here in the text, that is kind of a variable, and in the backtricks, which I put it here, that text is basically this goes here, right? And then I'm asking to summarize in a single sentence. And then I'm getting the response and printing the response. And the output comes based on this particular text, the guide to a model towards to a desired output and reduce the chance of iterations or incorrect responses. It is important to provide clear and specific instruction which may require longer prompts or more clarity and context, right? Now, people sometimes think that, hey, is it a backtrace I always need to put? Or there is some other technique? No, it's not backtrace. It could be anything. And there are some examples I have put it. It could be a triple quotes, could be a backtrace, could be a dashes, could be an angle bracket, could be an XML tag, could be anything, right? Which can separate it out, which can understand by the model where exactly the test goes. That's why you need to separate it out. And you give a very specific, clear instruction what need to be done. So I hope it's clear the tactic number one. Now we'll go to the next tactic. Tactic number two. Always ask the model to produce a structured output, right? If I ask you a question and if I tell you that at the same time to answer, you need to respond back to be a bulleted list. That means you're not gonna read a paragraph to me, you're gonna read me a bulleted list. Same thing goes to the model. If I ask a questions to the model, and if I want the model to respond me back to some structured output, could be a bulleted list, could be a JSON, could be an HTML, could be anything, right? That has to be clearly mentioned in the instruction. So always you need to make sure you have a structured output. And see this example, in the prompt I said, generate a list of 3 made-up book title song with their authors and genres. Provide them in JSON format with following keys: book ID, title, author, genre. See how clear that not only the instruction, but I'm also telling the output has to be a JSON tag, right? And these are the keys of the JSON. And if I run that one, I get a JSON output, right? And this JSON things, you can take it and post process for your downstream applications, which could be much more benefited rather if it, let's say, responds back to kind of an one sentence, right? Which sometimes again you have to post process with some other techniques. It doesn't seems to be good, right? So always you need to have a structured output in your prompt instruction. Third, ask model to check whether conditions are satisfied. Very important tactics. You need to remember this is very important. And we're going to dive deep more in the subsequent slide why this is important, right? But this tactics is helps you to give you the right answer. Same goes to a human. If I ask you a question and I want you, before you answer that question, make sure you validate all the conditions are satisfied before you respond back to me. Same thing here. I'm making a prompt here. I'm telling that making a cup of tea is easy. First, you need to get some water boiling. While that's happening, grab a cup and put a tea bag into it. Once the water is hot enough, just pour it over to the tea bag, let it sit for a bit, and then tea can sleep. Tea can step. After a few minutes, take out a tea bag. If you like, you can add some sugar or milk for taste, and that's it. You're gonna get yourself to a delicious cup of tea and to enjoy. In fact, after reading this one, I wish I could have a cup of tea or a coffee. Anyway, yeah. So and see, this is my text, right? And in the prompt, I'm saying that you will provide it the text with the delimited by backtricks quotes, right? If it contains a sequence of instructions, rewrite those instructions in the following format: step 1, step 2, step 3, step 4, go to the step n. And if the text does not contain a sequence of instruction, then simply write no steps provided. See, then I'm putting within the backtick the text and then asking the output, right? And here's the output. So this output step number one, get some water. I'm sorry, before water boiling. Grab a cup and put a tea bag on it. Step three, once the water is hot enough, pour it over the tea bag. Step four, let sit it for a bit. The tea can steep. Step five, after a few minutes, take out the bag. Step six, add some sugar or milk for taste. Step seven, enjoy the delicious cup of tea. Right? So this very sequential steps, how it came up, because we tell the instruction, the prompt, that you need to rewrite that instruction in the following format, right? And if these steps does not have any sequence, there's a no steps provided. So before it picks the actual output, the model itself goes and makes sure all the steps are validated as satisfied. And because you see there is no steps provided, no steps, I mean there is no such step 8 or something like that says no steps provided, because it's validated and it makes sure to make a tea whatever is required, the steps is all is there, and that's why it's telling you. I hope it makes sense.
Yeah. Yeah.
Let's go to the tactic number 4. Provide example. That's why I said beginning, right? Example is very important. It's also known as few shot prompting, right? Let's take the same human analogy. If I ask you a question, right, and if I do not provide you the examples, you can give me the output for sure. But if I give you an examples, right, hey, this is my question, these are my examples, then it's for you, it's very easy to understand, very easy and fast way you can compute in your mind what exactly I'm looking, and you will give me the result, right? Same goes with the large language model. You have a prompt, you provide some examples. For example, here, your task is to answer in a consistent style. Child is asking, teach me about patience, right? And the grandfather is responding, the river that creates the deepest valley flows from a modest spring. The grandest symphony originates from a single note. The most intricate transparency begins with a solitary thread. These are the examples grandfather is given for the teach about the patience. Now the child asks another question, teach me about resilience, right? And see how the grandfather is responding. Resilience is like a tree that bends with the wind but never breaks. It is the ability to bounce back from the adversity and keep moving forward, even when things get tough. Just like a tree that grows stronger with each storm it weathers, resilience is quality that can be developed and strengthened over time. So this kind of a Shakespeare-oriented literature is coming out of here, right? It's pretty much matches the way I have given this example. So it's important the tone which I'm expecting, I provide the same tone in the prompt. So it is important to give you the right response in the right tone, which is called few shot prompting. And if you don't provide the examples, you will get definitely what is resilience means, but may not be the same tone, right? You will get the answer, right? That's called zero shot prompting. Means that you do not provide any examples, but you still get an answer which could be satisfactory for you, and that's you know that's okay. I'll not say the best, but that's okay in some applications, but not the best. For the getting the best, you need to provide some examples. Always do that. And now I'm gonna, and again, these are 4 tactics I listed. It's not the all, right? There could be many tactics like that. These are the very common tactics you can employ into your applications to give up a better output or do a better prompt engineering. Now I'm going to switch gear and talk about the principle number 2, which we tell that give the model time to think. If I ask you a question, I need to give a time to you think, right? Now, for this tactic, specify the steps required to complete a task, right? And I'll go a little bit deeper on the technical aspect of it, but let me first tell in a very high level, what does it mean? So I provided a text And in the instruction, I say that your task is to perform the following action. First, summarize the following text delimited by triple and the triple angle within one sentence. That's a clear and specific instruction. Second step, translate the summary into French. Third step, list each name in French summary. Fourth step, output a JSON object that contains the following key, French summary and the number of names, right? And then I use the actual text, the summary, translation, name, and the output JSON. And then I provide the text in this particular triple backend. And I'm asking them. Now see that when I provide that, I get completions prompt two, which is summary is this one, translation, because this is the following way I ask, right? That summary, and then the translation, right? Then I ask the names, then I ask the output JSON. Now you might be thinking, where time to think concept comes in? Time to think concept comes in because we are providing more and more and more detailed instructions in the prompt, right? So model has to think, okay, first I have to summarize. Then I have to translate that summary to a different language, French. Third, I have to list the name in French summary and then the output in a JSON. So I'm providing more detailed instruction so that the model can think, okay, first thing I need to do this and this and this and this, right? And then I'm also telling the format, which the format or the sequence of format I'm looking, expecting the output. So that's what I'm saying. You have to provide model time to think. Now I'll go a little bit deeper and on the technical side of the story, why this is uh, time to think. In a large language models, um, time to think is means give more compute, right? If I provide a more time to you and ask you a question and to answer me back, in your brain you are parsing and you are trying to translate yourself. Okay, what need to be done? You are doing some computations in your mind because the more time I give, you will get more time to think about. So in large language models, we're providing a detailed instruction, means we are telling, okay, these are the things, and they can get more time to compute. But how the compute works? Through tokens. Means each tokens is kind of a concept that it's not necessarily each word is a tokens. Tokens is just a numeric number, by the way, from a given word. And one word could be just one token or just more than one token, could be two, three, four tokens, right? And in fact, if you go to the OpenAI, you can see the tokenizer and you can pass a text and give you the exact token counts from that. I'll not go that part yet. But the more text you provide in a prompt, the more token you are consuming. The more token you are consuming means that large language models has a more tokens in his context and it can get more time to think, and token is equivalent a compute in the large language model. That's the reason I said the more you give or the provide, it's giving more time to think for the large language models to give the better output. So that's one, number one. Second tactic on the principle two, instruct the model to work out in its own solutions before rushing to a conclusions, right? It's very important, and it basically goes more on the reasoning kind of a concept. For example, here if you see that determine if a student solution is correct or not. The question, I'm building a solar power installation and I need a help working out for the financials. Land cost $100 per square feet. I can buy solar panels for $250 per square feet. I negotiated a contractor and maintenance that will cost me a flat $100 per year and additional $10 per square feet, right? So that's a negotiation. See, that's the how the getting complex. Now, what is the total cost for first year of operations as a function of the number of square feet? Now, here I'm telling that the student's answer, let's X be the size of the installation of the square feet, right? By the way, this is not students is producing. I am giving the models, to think and also, try that same reasoning and the math behind the scene with that kind of an explanations or the reasoning so that I can get the proper answer. So I said X, so land cost is 100x, solar panel costs 250x, then maintenance costs 100,000 plus 100x, that's this one, and then total cost is this, right? Now, then I'm asking that um, um, get the actual output, right? Here, I am providing this one, but I did not say that, hey, this is the student's solutions, by the way, the actual student is provided. And I'm asking model to verify, and model is saying this is correct. But this is wrong because they did not factor the negotiations part here, right? But how I can fix it this one with the same principles? Like this. I said, okay, this is the question, your questions here, your actual student solutions here, right? And then model's actual solutions and steps to work to the solutions you goes here, then students grade, right? And then we provide here the actual question, the student solution, then the actual answer. But in this prompt, compared to the last prompt, I do not have anything. I have actual prompt and the student solutions, right? What the students have provided, and then asking. But here, I'm telling model your task to determine if the student solution is correct or not. To solve the problem, do the following. First, work out your own solutions to the problem. Then, compare your solutions to the student solutions and evaluate if the student solution is correct or not. Don't decide if the student solution is correct until you have done your problem yourself. Same thing. If I ask your math and if I ask you the answer back to me, what do? You first try your math by your own and see if the answer is correct. Then you respond back, right? Same thing here. Your question, which is this one, then student solutions, which is this one, and student solutions here means that what solutions actually come out, the output, right? Then actual solutions, where the model is providing the actual solution, and steps to come up to the actual solution. Then you are judging your actual solution with the student's grade, whether the student solution is correct or not, and then you are providing the grade. And then you are asking the output. And in this case, say we did the same thing. Let's the output. If you print this one, you'll get the output like this. Let's x be the size of the installation of the square feet. Land cost 100x. Solar panel on this one. Maintenance cost 100k plus 100x. Total cost is 10 250k. This one plus 10x, so 300x plus 100k. The student solution has the same solution, just calculated. No, it's not that because they have not calculated the same thing, right? They're saying the student solution is correct because here the student solutions is 450x plus 100k. In fact, I know to switch. In fact, I'm switching here, right? That's the actual solution. But the actual solutions is 360x plus 100k, not 450, right? And that's the reason the student solution is incorrect. So this kind of a things it comes up, you need to always instruct the model to work out first in their own solution and then compare with the actual solution and come up to a conclusion, right? Now, that's kind of a couple of techniques I taught you that what are the different techniques you can use to write a better prompting. Again, these are not all. There are many, many techniques. But now I'm gonna tell you that what are the different techniques for advanced prompt engineering. And in fact, once you go to that subsequence, and then you will understand that before I talked about the few shot learning, the reasoning over that, you'll understand where this comes from, how the techniques or the tactics has been developed. It is not just something arbitrarily coming out of some community work. It is based on the science and research paper. Those techniques has been proven. Now we'll go to deeper on that. First of all, these are the techniques I'm going to teach you in this particular topics, which is few shot prompt, chain of thought, self-consistency, knowledge generation prompting, programmated language models called PAL, and then reason and act, which is called React, and the last but not, which is very important, RAG, which is called Retrieval Augmented Generation, right? So let's start with few shot prompt, right? So the few shot prompt, in fact, in our first, second or third slide, we talked about some examples, right? Which is called few shot prompting. And few shot prompting allows the models to provide some allowed, basically we provide some examples to the models, and model can steer towards those examples to give you the better output or the better performance in a given tone, right? So here I'm saying that these are the input, the examples I'm providing, say that the odd numbers in this group add up to the even number is 4. And the 4, 8, 9, 15, all these things, and the answer is false, right? Second example, I'm giving true. Third example, I'm saying the answer is true. And like that. So I'm giving almost 4 examples. Then I'm asking a question. The odd numbers in this group add up to an even number, and I'm giving these numbers 15, 32, 13, 18, 82, 7, and 1. And model says that, okay, the answer is true. Behind the scene, it says that, okay, I have provided these examples. It understands that, okay, these are adding up. It's doing the calculations. That's how I'm giving the answers true or false. Well, this given the question, it do the calculations behind the scene and give you the actual answer. So having an examples is always good in your prompt, so that you can steer toward and get the actual results. It's very important. And second is a chain of thoughts, which is COT prompting, right? And in fact, this I've provided a source here, the chain of thought. It is came out of a research paper, which you can go and search later. But what is the crux of it is that you are telling the model to think step by step with some reasoning, and then response back, right? Which is called chain of thought. And you can combine that in a few short prompt as well with the chain of thought. And chain of thought also right now, in the last couple of months, it came out of a research paper called zero shot chain of thought. So in a chain of thought, you can provide examples so that model can understand what is the different thought process has been involved with that example. Or you do not provide an example, but you can write a single statement. We'll go later on that. I'll tell you that was that in a next slide. And that will understand before it output it, it has to go through some sort of thinking process behind the scene. So zero shot, and again, this is a research paper I listed here. Just say this particular sentence in your prompt. Let's think step by step. So we are not providing any examples. Rather, we are providing a line in your prompt, right? And by the way, when you go to some demos, we're going to show that. So here, the original prompt was like this. I went to a market and bought 10 apples. I gave 2 apples to the neighbor and 2 for the rich man. And I then went and bought 5 more apples and I ate 1. How many apples did I remain with? Then it just say that 11 apples, right? Which is not right. But if I say on the same question, let's one more line if I add, let's think step by step. Then model gives what? More time to think. As I said, the principle, you need to give more time to think. When you say that, let's think step by step, means you are telling model time to think. And at the same time to think means putting a lot of basically tokens has to be consumed, and which give the compute to thinking of the model. Now here, first step, you started with 10 apples. Then you gave 2 apples to the neighbor and 2 to the rich man. So you had 4 apples left. Then you bought 5 more apples. So now you have 11 apples. Finally, you ate 1 apple. Then it remained 10 apples. But if you don't put that line, your answer is 11 apples, which is wrong. So think about how powerful just adding one line in your prompt get the right answer. So that's called zero shot chain of thought. Now, why it is zero shot? Because we are just adding a line, but we are not giving any example steps in the prompt. If you think about the regular chain of thought, which is not a zero shot, then typically what you do, you just add a couple of examples, like instruction or steps that goes through that thought process and then give you the right answer. You will get same thing. But then now you'll be asking that, hey, whether should I use zero shot or whether should I use regular COT? Just give me an example. What I said before, the principle, it's an iterative process. I cannot tell you that only zero shot gonna work or the exemplars chain of thought gonna work best for your application. You need to try it out. right? You need to test it out. It's an iterative prompt development process and see which one you are getting a right answer, right? That's why you need to decide. I hope it makes sense so far, right?
Yeah, I'm following so far.
Awesome. Now, other technique is a self-consistency. What is self-consistency? So self-consistency is basically kind of you provide a sample, multiple, diverse reasoning part with a few short of kind of a COT approach, and then you ask to generate some sort of consistent answer from there. And from that consistent answer, you are telling model which is the most voted kind of a thing, which is the most weightage answer. You pick that one. That's called self-consistency. Why it is designed? Is designed to basically improve the naive greedy decoding in your chain of thought prompting. Now, what is naive? Greedy is a mouthful word, I know, but the naive greedy decoding. Think about in a NLP kind of a concept, right? Where you have an input and you get a probabilistic output. All the probability next sequence, the word you'll get an output, right? Not an output. The next possible probabilistic word in your statement, right? Now, and then what it does is basically whatever the most weighted probabilistic the sequence, you pick that one. That's called naive decoding. But it's not always the right things to use the naive greedy decoding. And in fact, let me share you with this one, right? For example, this naive decoding, I just pick it from this article. That here you see that it begins with the partners who are forming a five-man war cabinet, which include a chairman and the Lord President of the Council, labor leader, cabinet athlete, That's a very tough word, by the way. The late Deputy Prime Minister, Halifax and Foreign Ministry, and Lever author, Mr. Blah, blah, blah. And then it says that in practice, the cabinet was divided into three parts: the cabinet of ministry, the cabinet of ministers of the crown, the cabinet minister of the crown, and then the cabinet of the minister was most important part of the government. And then this piece is getting a higher weighting and keep on repeating the same word, right? That's called naive decoding, graded decoding. It's understand the next possible probabilistic distributions, which has been already calculated, and try to choose that option with the highest probability, because that's go to the highest probability, which is not always right, right? Which is makes sense in most of the cases, but not always right. And to solve that purpose, the self-consistency actually comes into the picture. So it means that you provide some examples and the questions, and then you come up an answer and try to see which one most voted, and then you go from there. For example, in this one, right? If I ask, when I was 6, my sister was half of my age. Now I am 70. How old is my sister? It's a 35, which is not quite correct, right? Right? And also how you can solve that problem with a self-consistency example. And by the way, self-consistency is nothing something came out of community. It is an research paper has been published, and that's why it's been produced. Now, in that self-consistency, you see this how they have said this is the question, right? And in that question, this is by the way the exemplar question, not the actual answer of the question. So there are 15 trees in the grove. Grove workers will plant trees in the grove today. After they are done, there will be 21 trees. How many trees did the grove workers plant today? Then I'm providing some answer for that question. We start with 15 trees. Later we have 21 trees. The difference must be number of trees they planted. So they must have planted 21 minus 15, 6 trees. The answer is 6, right? And then I give another example. Then I give another example. Then I ask the question. When I was 6, my sister was half of my age. Now I'm 70. How old is the sister? Then it outputs are different outputs. Means it try to solve the problem in a different ways, right? If I say, okay, I want to get 5, 5 can be done by 2 plus 3, right? That's the one way. Or I can say 4 plus 1, or I can say 0 plus 5. All are correct. So it means that to get to 5, I not only have just one answer or one way, 2 plus 3, I can provide multiple ways to come to the conclusions 5, right? Same thing. So here what it does, I provide the question, it try to solve the question in a multiple way. First output is when I was 6 years old, I mean six, my sister was half of my age, so she was three. Now I'm 70, so she should be 70 minus 3, which is 67. The answer is 67. And previously, it said the 35, which is not right, right? So now we get first output 67. Now other way to get that. When the narrator was 6, his sister was half of his age, which is 3. Now that narrator is 70, history is 70 minus 3, which is 67, right? And then other example, the narrator was 6, sister is half of the age, 3. Now that was narrator is 70. So it's trying to come up to a different ways, the examples I have provided here, because here I provided a 3, but um, uh, I'm not, I'm asking about the age, but I'm providing an example of tree, example of parking lot, another example of the buying something from $1. So different examples I'm providing to come up the right answer. Same thing is try to do the most one, and maybe fourth output could be just, for example, it could just be 35, but while it give you the answer, it will not take to the fourth output because the majority voting is 67. That's how you get. So it will take from that, and that will give you that called self-consciousness. Now we're going to go to the next one. It's called generate knowledge prompting, right? So this techniques is involves additional knowledge provided as part of the context to improve the complex tasks such as common reasoning, right? And it is very similar to we're going to talk about the RAG approach in the later, but it's very kind of a very similar, but it gives you the high confidence prediction is used in the knowledge, right? So in fact, this particular screenshot I've taken from the research paper itself. So you have a prompt, you generate questions from that knowledge prompt, and then those questions feed into the knowledge integration, and then you get the actual answer. So how that practically works is that, so generate knowledge prompting is the first step is to generate knowledge, and below is the example how you can generate knowledge. So input is Greece is the larger than Mexico. The knowledge which I provided, I'm not telling in this time yes or no. What I'm telling is Greece is approximately this much of square feet as a square kilometer, while Mexico is approximately this one, making Mexico 130% larger than Greece. So that means what? That means Mexico is larger than Greece. Second, I'm putting in another rock example. A rock is the same size of a pebble. Knowledge. A pebble is a class of a rock with a particles with a 4 to 64 millimeter based on the ultra within all this thing, blah blah blah. Then it generate knowledge out of it. So this is the input and this is the knowledge. Then again I put an input and I'm asking to provide me the knowledge out of it. What is the input I provided? Part of the globe is trying to get higher point total than others, and then I'm getting a two knowledge from that. First of all, this is the objective of the golf is to play the set of holes in the least number of strokes. A round of golf typically consists of the 18 holes. Each hole plays once in the round of a standard golf course. Each stroke is counted as 1 point, and the total number of strokes used to determine the winner of the game. Another knowledge has been generated. Golf is a precise club and ball sport in which competing players or the golfers as many types to clubs, it blah 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 blah. Right. So these are the two knowledge is generated from that given input. Then what next? Then here is it comes. Then what I did in this example is that the knowledge samples are then used to generate knowledge augmented questions to get the final answer. And then the highest confidence is taken for the final answer. So it means that we said part of the golf is trying to get the higher point total than the others, yes or no. Then the knowledge which has already been generated before, we feed on that and then give you the actual answer. No, the objective of the golf is not to get the higher point total in the others. Rather, is object to play the set of holes in the least number of strokes. Then the total number of strokes is used to determine the winner of the game, right? That's the high confidence. Whereas the other one, the part of the trying to get the higher point, the same question I'm asking, yes or no. But I have two knowledge generated before. Then I'm passing that knowledge. Golf is a particular glove, the precision club and ball sport game and all of that, right? Then I'm asking based on that knowledge the same question, then saying the answer is yes. Part of the golf is trying to get the higher point total than others. each player gets their compete with the codes like that. So both the questions and both the knowledge, I ask the same question, both the generated knowledge, and I get the answers out of it. Once is yes, once is no, with the explanation, right? Out of this is give you the confidence, which because this one has a high confidence in terms of prediction than this one, so it chosen this one, right? That's called generate knowledge prompting. So you generated knowledge from a given text, then you use those knowledge to an actual question and see which one gives you the higher confidence for a prediction. That's another thing. Next one is a program aided language model, which is called PAL, which is a very important, especially the reasoning kind of a concept where you have a lot of kind of a mathematical problems you need to solve, and in fact large language models tends to be more on the text based kind of an use cases has been solved, but it is not quite good on the mathematical aspect, right? And that's where you have to use different techniques to solve some mathematical problem. In fact, I saw some I think maybe 2 3 weeks back OpenAI has released and say that hey, they have came up some sort of models, definitely GPT models, to perform complex mathematical tasks. I don't know how they have been done, but they are claiming that GPT models can do a complex mathematical task as well, which was not there before, which is good. But PAL is one of the, I believe they might have using some sort of PAL technique behind the scene, which I don't know. But PAL technique is basically it's same chain of thought prompting and steer the models to perform a better reason over to give an output for a given task. But sometimes this is not enough because, especially when I say the mathematical problem, it sometimes fails on that aspect, right? So you need separate tools which can read your problem and give up actual reasoning steps, right, behind the scene, and it give you the actual results, right? And the PAL could be a Python interpreter, right? You can offload the solutions to a Python interpreter tool, and Python interpreter will actually execute your statement or the actual problem and give you the actual result, right? How that looks like. For example, here I say that Roger has five balls and five tennis balls. He buys two more cans of tennis ball. Each can has three tennis ball. How many tennis ball does he have now? Right? Even though if I use kind of an chain of thought kind of an approach, you can do that. I'm not saying in chain of thought you'll not get the actual answer. You may get, right? But here I'm talking about offloading that calculations to a different tools or a different hold together a different kind of an system which typically execute, literally execute and give you the actual answer, right? So here, then, so by the way, oh, I'm sorry, this one is an input, I'm giving an answer for that, and then I'm giving another input, and sorry, let's keep on going. So in a typical chain of thought, I'm giving an input, I give an answer, I ask the question, right? And I'm trying to get the answer. Here, the answer is 62. So you see that sometimes chain of thought fall off, right? It didn't work well. The answer is not 62 in this case, specific to this example, right? Now, if I do a chain, PAL approach, which is you have five balls, he buys two more cans of tennis ball, which each can has three tennis balls. How many balls? So Roger started with the five balls. Tennis balls equals to five in the variable. Then he bought another three, which is two times three, and then get the actual answer. So this one, actually, this is happening behind the scene a Python interpreter. By the way, it is not happening by human is coding that one. And you will see the model output. You will pretty understand who has a Python familiar. It'll give a sort of Pythonic way to give the answer. So, long story short, what I'm trying to message it from here that a chain of thought reasoning is definitely a good approach. You can provide different steps which can come up to the actual result. But sometimes in a complex mathematical situation, the chain of thought might fall off. And here's the example, right? And that's where you use the PAL approach, where you are offloading the actual calculation to a Python interpreter. Python interpreter do the actual calculation and comes back to you to the actual result. And that's how it works. Is that? I hope it makes sense, right?
It does. It does. if I want to learn how to do that, do you have examples
Yeah,
or?
yeah. I'm going to go through that some of that demos. Let me finish up the theory
Okay,
part.
okay. Just
Yeah,
getting ahead of you here. Yeah.
sure. Yeah, so here, and by the way, this is the research paper I mentioned, which is basically
Mhm.
talks about the PAL approach. Now, reason and act, very important. And this is one of, I'll not say the best favorite, but one of my favorite, the framework, the React approach, right? So the React approach is a framework where large language model is generate both the reason and act on top of that reason, right? In a very interval manner, not just one reason, one act. It will go to the iterative manner to come to the final conclusion. So first, generating the reason traces that allow the model to induce some sort of plans of actions or what the models need to perform the actual reason part, right? And on that, which is called thought process, by the way, and then you take an action on that thought process, which is the reason has been produced to come up to the actual result. And it can, and React not necessarily has to be, it can extract some information from the website, could be anything, right? Or maybe from internal source itself. That with that reason and act, you'll go along and then come up to the final result. And React allows more external tools to it, to interact with to come to the final response. And if you are familiar with the LangChain, which is a pretty good framework in the large language model, and I'm a fan of it, they have implemented the React framework in their toolset, which will go to you ask a question, which is basically React comes in some sort of agent concept. I'll not go deeper on the agent, but in short, agent is think about a program which is basically takes your input and it understand what the next step I need to perform, right? And how I need to perform it, understand that concept, and accordingly perform it and give you back the large language model to the answer. So let's go deeper on the agent topic, but React has been implemented large language model in the LangChain and you can use their form as well. Now, in the React, I'll give you an example here. And by the way, this is again came out of the science paper, which I listed here. And this is the hotspot QA data set. And here is saying that aside, and in fact, this one I taken from the this research paper. And in this research paper, I say that aside from Apple's remote, what other devices can control the program Apple remote was originally designed to interact with? That's my question. If I go with the standard reason, not the React or the right side, just don't focus on this right now. Just focus on this particular segment. This is the standard reason only, kind of a chain of thought. So thought, I say that let's think step by step. If I add that, what will happen? Apple remote was originally designed to interact with Apple TV. Apple TV can be controlled with the iPhone, iPad, and iPod Touch. So the answer is iPhone, iPad, iPod Touch. Right? This is wrong because this is just reasoning, right? Is not taking an action on the reason. Whether I'm reasoning, is it correct? I don't know. I'm just taking a reason. That's a siloed reason. Now, if I just take a siloed act only approach, right? I say, okay, search, I'm searching, and this search could be anything. As I said, React can work with the external sources. And let's say I'm doing a Bing search, for example, right? I say Apple remote. What I get an observation, that's my action. And observation is the Apple remote is a remote control. That's my observation. Then I do the again search, right? Front row, because I did say that what are the devices can programmers originally design for? Then could be find front row or similar like that. So what I'm trying to say, the second example here, it's a multiple things you can search through, right? And you can give the example. So you can act based on the observations, right? You act this one search and you get an observation. So you search something different, you get an observation. You ask something front row software disconnected media center. Then you final finish it because yes. So is that the answer is the Apple remote is originally designed for interact with? And your answer is yes, right? Which is also not quite correct. Now, what the paper is saying that we can combine this together. Not only do have a siloed reason and the siloed act separately, let's combine this together and come as a react, which is reason over act. So first I need to say that thought process. What I need to search Apple remote to find the program it was originally designed to interact with, right? And the action is going maybe a Bing search and it's coming out this observation. Apple remote was the remote control introduced in 2005, originally designed to control the front row media center program, right? Then second thought process go, and it's a chain, and it's not just somebody you have to manually input it. It's go to the second thought process. And by the way, this goes by the agent concept, by the way, I was talking about. Then Apple Remote was already designed to control the front row media center. That's why it's coming in the first thought process. Then second thought process goes on that, right? Front row. And again, do the act on that. Then third observation goes on that and keep on going. And finally, in the final thought process, you can say, okay, front row software is controlled by an Apple remote and the keyboard of function. So the answer is keyboard function keys and the keyboard function. That's the final answer. So it goes to a multiple thought process, the observation, which is basically you're from the thought process, you're taking an action on that. Again, you go to the observation, thought process, and action. So it's keep on iterating through that and came to a final conclusion rather than siloed to this one and that one. That's called react. So it's basically the reason, and you get a reason, you observe the reason, you take an action on that reason, go again and again and again, and then you conclude to your final conclusions, right? That's it's called react.
Good example. Good example. Got it. You had a lot in there very concisely, actually. Yeah.
No, thanks.
Yeah.
And this is my favorite, Retrieval Augmented Generation, which is called RAG, which is also came out from this research paper. And the reason I'm saying favorite, and I'll tell you a practical examples of the RAG so that you will understand why it is favorite. And most of the enterprises have some common questions. Let's park that common question. Let's talk about the RAG, and then now you might think, why is this guy talking about without explaining RAG? Let me explain that. Okay, so RAG is an approach where the natural language systems, basically the processing system, both uses a retriever-based and retriever-based and the generator-based method to give you the final answer, right? So what it does is basically, and again, these screens are taken from the research paper. You have a two system sitting together, a retriever system and the generator systems. What this does is the generator systems is basically generate. Think about the knowledge, right? It generates a knowledge and stored somewhere, right? Somewhere. We'll go more deeper where it can be stored, but somewhere it's stored, right? And the retriever knowledge, which is basically retriever system, which basically you ask a question, and that retriever knowledge is said, okay, I have a question. I need to search that question from the database where generator has already created the source form. Then go to that source and give you the answer, right? So that's called RAG. You have two systems. One system generate the knowledge, and other system, based on the user input or the prompt, is trying to get the answer from that knowledge. That's called RAG, right? And it's pretty common, such as question answering use cases. Sort of even, in fact, some of summarization, I have seen that use case as well. But more typical use case is question answer. In fact, which is true, and I'm serving HLS customer, and in fact, all my HLS customer use case are question answering from their corporate documents. So they don't want, and they have a lot of confusion that, hey, ChatGPT has been trained on the public data set. And if I provide my own data, is it going to be trained the models by my own data? No. Azure OpenAI specifically does not use customer data to train the models, right? We do not do that one. So then how I can use my own data to question and answer, right? What is the mechanism for that? If you don't train the data, should I have to do the fine tuning? Should it means that I will take the base models from you and I provide my own data to fine tune it? No. Fine tuning, we do not recommend to use it unless it is really super needed. And I have not personally found any of my customer is doing fine tuning yet, right? Now you might be questioning, okay, what is the difference in fine tuning and the RAG, right? If I don't have to do the fine tuning, why do the RAG? So the fine tuning is, think about, I'll give an analogy, right? Let's say you went to a school from grade 1 to grade 12. You studied math, physics, chemistry, biology, all of the different things, right? So you know many things. That is typical pre-trained model, which is a base model, came out of generative AI, OpenAI, right? It has many things. right? Then you go to a college and you basically give me 1 second, just some background noise, just a second. Okay, I'm asking my daughter to skip silence. Okay, sorry for that. Okay, so I was talking about, yeah. So after you've done the grade 1 to grade 12, you basically go through all the things, and that's called pre-trained model. Then you went to a college and you studied, let's say, electrical engineering for 4 years, right? So these 4 years, you are specialized only to electrical engineering, even though you know the fundamentals of all of the things, science, biology, maths, and physics, all that. But the 4 years, you only do electrical engineering. That is called fine tuning. Means you are specialized to do only electrical engineering, nothing else, right? So in a your term, if you want to do a sentiment analysis from your textual document, then you can fine tune your model and provide lots and lots and lots of examples of your the actual, the sentiment, like text sentiment, like that, right? And that examples you can feed into a large language model to fine tune it, and there's a process to do that. And when you do the fine tuning, definitely there are weights are changed, and weights changes mean it doesn't weight change the actual, the layers of the models has been trained on. They use some, I believe, OpenAI, that is not disclosed, but they use the PEFT, which is called the parameter efficient tuning, and they use might be LoRa or some sort of techniques to basically fine tune and extra parameters to change the weights of that, right? We'll not talk about the PEFT and all these things, detail technical here, but that is basically you are specialized to do only sentiment analysis, specialized to do only electrical engineering. That's all, right? Nothing else. That's called fine tuning. Now, the RAG is little different, right? And there is a problem also. I'll talk about the fine tuning. The problem here is that it is not that easy. It's very complex. Technically, it's very complex. Second thing is generating lots and lots and lots of example is not that easy. You need either a human annotator who can generate that. I know there are some papers coming out like Stanford and Archa, all those things. What they do basically, they generate the example using a large language models, right? Which is a way you can do that. But in long story short, you need to have an example, which is not that easy process. And then it's required a lot of compute and lot of money you need to spend to fine tune. It's not that very cheap. It's very, very expensive, right? Now, on that, even if you do the fine tuning, and if I ask you a question, you cannot cite it, the answer, because the fine tuning, the information is all embedded with your actual pre-trained data, right? So it's very hard to tell where the answer source from, whether it is sourced from your fine-tuned data or is it sourced from the actual model internal pre-trained data. You don't know that. It's very hard to cite it that one. And that's where the RAG comes into the picture, which is called retrieval augmented generation. Means that you have a source of document, you don't go with the fine tuning, you store it with some sort of database, you ask a question, give back the answer, right? And that way, it is basically, if I take the same analogy of the electrical engineering, after 4 years of electrical engineering, you went to a job, and in the job, every day you are learning new things. It's not just 4 years of electrical engineering things you learn. Every day you are learning new things, new tips, new techniques. You cannot do every time fine tuning. It's not possible, and it is not appropriate, not logical. And that's where it's use the you basically all this knowledge which you are generating, you put to some sort of knowledge base and you retrieve as and when required. And in practically, if I ask how that in Azure OpenAI, think about this step, right? First of all, you have a lot of internal corpus documents. You have that one, and then you chunk it up. Why it is chunking? Why I'm chunking this up? Chunk means a smaller version of this text. The reason I'm chunking is two reasons. First reason, every large language model has some sort of token limit. For example, GPT 3.5 has 4096 tokens. GPT-4 comes with a two flavor. One is the 8K token and 32K token, right? Now, what is this token? I told you before, tokens is, think about, it could be, one word could be one token, it's a numeric representation, or it could be one word, multiple tokens. Now, if I ask you, for example, I want to generate the knowledge of those documents, end of the day, I need to get the numeric representations of the data. That's how I need to do. But I cannot feed the hundreds and thousands of pages into a single API call because there is a context issues, right? I cannot go beyond certain the token limit. That's the reason you need to do the chunk. And second reason, which my favorite, is that if I ask you that, hey, you need to go for open book exam, and if I give you 100 pages of book, no think about no index, nothing that, and if I ask you a question from that, what are you going to do? You have to search almost all the pages to give you the right answer, right? Which is not efficient. However, if I give you a one page from that 100 page and ask you a question, it's very easy because you are searching the question of searching the answer of that question from that page only, right? So chunking, it makes, first of all, removing that token limitations issue, and second thing is much more efficient to give a very contextual answer from that given question, because I need to give answer from that chunk. So that's the reason you do the chunking, right? And then you use some sort of OpenAI embedding models, which is called ADA embedding. What is embedding? Embedding is, think about numerical dense representations of your text to a n-dimensional vector space. I know it's a very mouthful, but that is it means that you create some sort of numerical representations, and that representation you plot to a vector space. That's it. Dense representation, by the way, right? Why I say the dense representation? Because there is another vector called sparse vector, right? So dense vector, sparse vector. I'll not go that deep on that, but there is a sparse vector, which is lot of zero values can be exist in the sparse vector, and dense vector is a lot of non-zero values can be exist on the vector. That's called dense vector. And the dense vector is more, think about a contextually or semantically, correct context can be produced by the dense vector, right? There is a use case where you need sparse vector. We'll go maybe in a later top session on that. But in short, you created a dense vector using an ADA embedding model. And then you stored that into a vector database. In that case, Azure Cognitive Search. You stored that embedding. This whole piece, which I just talked about, in a RAG approach, that is called generator. This system is generator. You are generating the knowledge from this corpus and you are storing somewhere, which is Azure Cognitive Search, right? I hope it's clear up to that, which is generator. Is it okay? Matt? Okay.
I had myself on mute. Sorry. Yes.
Okay, great. So that's called generator piece. Now we're going to talk about the retrieval, right? We talked upside. Now you ask a question. Let's say in this case, GPT 3.5. This goes to the same embedding model because you need to get the same sort of numerical representations. And then you search from your generated knowledge using a cosine similarity, right? And you return back the actual contextual chunk which can suffice this answer. That contextual chunk then feed back to an OpenAI completion endpoint and it generates back you the answer. So this piece is a retriever. That is a practical implementation of RAG. You have a generator sitting, retriever sitting, you get the answer. The best thing is there is you get a citations. Means that now if you ask that model to ask a question, it can cite the answer because now it has a different chunks, right? It can say that for this question, maybe the PDF number 1, PDF number 2, and PDF number 3 is basically citing the answer. And I'm going to give you a demo on that so they'll better understand. So with that RAG method, you are grounding your model to answer the questions for your own data, even though OpenAI GPT model has been trained on the billions of corpus and open data and all of that, but it is not known about your data. And that's where you can ground the model to generate the answer from that. And this is a very fantastic approach to ground the model and generate the answer from your data rather than fine-tuning. This is very common things, and all of my customers are using the RAG approach to generate the question answering from their own internal corpus document, right? Now, let me give you a quick demo on the RAG, right? So that you'll better understand. For example, in this one, it's called chat on your data, which is enterprise data. Here, behind the scene, I have already generated the knowledge base, which is the generator part, means that I have a set of different documents, which I have gone through a chunking method, use the numerical representation of the chunk, and then store into a cognitive search vector database, right? Sorry, the cognitive search. In this case, I haven't used vector database, but if you want, you can use that one. And then I asked a question, right? What is included in Northwind health plan that is not standard, right? You see that it gives me very precise answer. That is a retrieval piece, right? And it cited this as well. It cited, okay, this is the actual PDF document has been used to source this answer. So as a responsible AI or principle of responsible AI is you always need to show your, the where the answer is sourced from. You need to provide that one, right? If you use the fine tuning approach, you're not able to provide that citation. That is not possible because at that point, all the weights and all the parameters are infused all together. So you cannot tell that where it comes from, whether it comes from a pre-trained data, whether it comes from the fine tuned data. No, you cannot do that. I mean, as for my knowledge, you cannot. But maybe in the future, then something came up and this is the way you can do that. But as for my knowledge today, you cannot do that. And that's why the RAG approach is much more better because you can cite it where it is coming from. That's number one. Now, it also gives some sort of thought process. I'll not go deep on that. It's saying that, okay, this is the actual your meta prompt, this is your system prompt. And then these are the source chunks, right? This is the chunk one, this is the second chunk, and this is the third chunk. And that's where it's coming from, right? And in this chunk is feeding to the actual, this chunks comes out of your cognitive search, feed back to an OpenAI, and OpenAI gives back the actual answer. Now, if I ask a very follow-up question, is it cover my dental, right? So it's a pure conversation, and that can say yes, Northfield plans provide that dental. Now you see that it's giving me all together a different source of documents, right? You see the previous source of document was different. Now this question, if I ask, it's give me a total different document. So these kind of a luxury and flexibility you will have if you use the RAG approach and if you chat your own data. So that's all I want to say about the RAG. And I'm gonna quickly switch my terminal to a demo because I promise I'm gonna give you a couple of demos on the different techniques which I talked about. But before I go to the different techniques on that, I hope is it clear about the RAG, why it is important, why people sometimes think that fine tuning is the best approach to go, and where you may not need fine tuning at the first time, rather you can use this approach to come up to your own result. Is that make sense?
Yeah, it makes a lot of sense, and it's pretty clear why you would use it, and it's more valuable than fine tuning in practical cases. Yeah.
Yeah, great.
Yeah.
Awesome. So we talked about other techniques in the before slides. So we're going to give a quick demos on that. So for example, here the same example which I provide, right? And if I ask that, in fact, all the things I ran before, if I run that one, it tells me this answer is false, right? Same thing in a chain of thought, right? I have the prompt, right? And in that case, that all of this group at the even number, if I ask that question, which is basically give me that the answer is false, which is giving the 41, right? This chain of thought. Now, zero shot COT, when I'm adding a let's think step by step, I go to the same example and I added just a step here. Let's think step by step. And once I get that one, it gives me a very precise thinking step behind the scene and give me the actual answer. When in this case, regular chain of thought, it does not provide me any sort of detailed explanations, but I do provide an example, right? In this case, this one my actual question, this is my actual answer, right? I put an example, and then I'm asking the question, I'm giving the answer. That's kind of a chain of thought. Now PAL, which is I thought you might be interested to see that one. This one is I provide define a large language model, define that the instance of it, and then I ask her which is the oldest penguin, right? And the penguin prompt is pretty much like this, right? I provided a detailed question on that. Sorry, you were saying something, man?
No. Keep going. Keep going. I'm
Okay.
following you.
Yeah.
Yeah.
Then how many penguins are less than 8 years old? Then put that in a Pythonic format. So I put here the Python list here, and then append all of the penguins details. Then I append another one, the James, and give the file answer. So this Pythonic interpreter, which I'm providing here, it can be used to come up to the actual. There are many examples. Then I come to the actual results, right? So when I run through that, it goes to that actual. You see that the examples it use the Pythonic nature in sort of lambda functions it uses to come to actual conclusions, right? Now you might be thinking that, hey, how do I do this Pythonic one? Should I have to write my Python code and all of that? Not necessarily always, because there are some tools are available, which is called LangChain, and LangChain has the Python REPL, the tools which you can use to do the offload the calculation to the REPL, and they can use from there. I also talk about the external knowledge generations and all that. For example, in this case, right? I use a LangChain here, and I said that I'm going to use an agent here, and I'm going to use some sort of tools here, right? And by the way, in a RAG approach, also, it not necessarily always has to data has to come from your knowledge store. It can come from external sources as well. So, as you know, the OpenAI GPT model has been trained on the public data till I believe September 2021, right? So it doesn't have any knowledge after beyond that cutoff date. But if you need to source any sort of recent things which is going on, if you need to get answer, you need to think about a RAG approach, which can take and it do some search from internet and feedback that information and give you back the result, right? And that's where it could come in. So for example, in this case, I have defined two tools. One is a search tool and one is a calculator tool, and I'm telling that this search tool is responsible if I ask very targeted question on the current events, and this tool will be responsible for some sort of math related question, right? Then I use a zero sort React. That's what I was talking about, the React. So in the agent, you define the React from a LangChain. And then I'm asking who is Olivia's Will's boyfriend and what is his current age raised to the 0.23 power, right? So now Olivia's Will's the boyfriend. First, what it does is, if you see, that's his action. That's all. Reason over React is reason over observation, the act, right? Reason and act is coming in here. So first input is, first they need to find Olivia's boyfriend. For that, the action is taking, it is searching from the internet. It's not going to the pre-trained data. And the observation is comes from us from internet is this one. Then he said, okay, then I need to find this particular guy's the Harry's age, right? Then again you go for a search, and it's come the Harry's age is 29 years. Then you need to calculate the 20 and to basically increase that age to some 0.323 power, right? Then use a different action that's called calculator, and that use that action to erase that, and it's coming up to the final conclusion that this is my final answer. So you see that in a one example, I just asked this question, and behind the scene, it goes a React kind of an approach, goes over at search, it get the result, and when you do the search, it's basically use RAG, by the way, at the same time, right? Because you feeding that information from different sources. Then you search, okay, this is the observation I got. Next thought is find the age of the Harry, and it get the find the age of the Harry for the another search. And then, okay, now I got the final age. Then you got to that another tool which I use, the calculator. Then you use the calculator to do some math and give you the final results, right? That's pretty much, it's called React with agent, with the RAG, everything all combined together, right? And this one I already demonstrated before, which is called actual RAG, which is this example to citate that data. That's pretty much I have for the demo. I hope this makes sense. If not, reach out to me. I can give you more detailed explanation on that. So long story short, to write a prompt, better prompt, there's a different tips and techniques are there. These are not all, but these are some of that which is very popular, and most of the customer are using these techniques to write a better prompt. That's one, right? And with all of these approaches and tactics, I'm sure you'll able to write a better prompting in your applications. But remember one thing, as we write the better prompt, you also need to think about prompt safety, right? There are a lot of prompt injection, jailbreaking, right? The prompt leaking. There are different the prompt related the safety features you need to employ, which can safety your prompt, right? Which is not part of the topic today, which we might be I'm going to record as other session on the prompt safety. You need to think about that as well, right? How you can safeguard your prompt. Prompt engineering is a definitely one of the aspects, but prompt safety at the same time is very important for the enterprises to safeguard the prompt so that somebody cannot hijack that prompt to inject some their own prompt, or somebody should not steal the meta prompt, which is actually the system prompt, and inject something different, right? So all these things you need to think about before you think about how to build a large language model applications and get it to a production. So that's all I have, and I'm gonna leave with a couple of additional slides here, which basically talks about the learning materials for you, and what are the best the prompting techniques like we do have in Microsoft. If you click on that link, it will be reached out. Sorry, to a page which talks about the prompt engineering and the different prompt engineering techniques and all of that. This is a really good one. In fact, OpenAI also came out of, I think it's pretty new, the best practices for prompt engineering. You can employ that one as well. Third one is a prompt engineering for developers, deep learning.ai. I highly recommend. This is the course, the deep learning AI taught by the Andrew Ng, who everybody knows him is a
Yeah.
god of the deep learning and the machine learning, and it also OpenAI version. I think her name is Isha. So Isha and Andrew has been talked to a different prompting technique. In fact, in my presentation, which I use some of their techniques to present you, so that you can get the first hand what it looks like. Highly recommend that. Pretty valuable information on that as well, right? Third one is a prompt institute. This is also you can get some current details, what's going on in the world in terms of the prompt engineering, how the enterprises, sorry, the industry is going, different tips and techniques. You can follow this one. That's really helpful. You have another one, prompt engineering guide. That's also very important. You can get a lot of prompting technique. In fact, some of the examples which I take it from here itself, which is called self-consistency, generative power knowledge, tree of thoughts. It's a pretty new. It's basically talks about different thought process and give a given ecosystems. It basically give you the final output rather than just one chain of thought. Multiple trees of thoughts it goes through and give you the final results. So there are different techniques has been mentioned over there. You can go through that. And yeah, that's it. So in fact, these are the learning materials I can recommend. Let me know if you have any questions. Feel free to, once this YouTube has been posted, mention, comment it, and all that. And I have, if you still need to get help, reach out to me on that YouTube channel, and you just post a question. I'll be happy to answer back over there. Yeah, that's all I have. Let me know anything else you wanna teach next. Get to talk next.
That was great. No, we covered a lot of material, and I definitely I'll want to get all those links in the description for this video, and I want to spend a little time with them myself. It's great stuff.
Okay, thank you. Nice to meet you, Matt, and happy to see you back again.
Take care, man.
Take care. Bye.